Hey, so you should be open to page 50 in your workbook. If you're not there yet, please pause the video and get there. We're talking about prime factorization, which we talked about earlier on in the year, so hopefully this will be a review. We've also done some bell ringer problems throughout the year, practicing it. But just wanted to go over it again just to make sure you absolutely understand it. So prime factorization, what you're doing is you're factoring numbers into primes. So first we need to know what prime numbers mean. So a prime number is any number that has only two factors, one in itself. So you can only divide it by one in itself without getting a decimal. And here they give you some examples of what a prime number could be. So 2, 3, 5, 7, 11, 13. You also have to know what a composite number is. A composite number is any number that's not prime. It's numbers that you can divide by stuff other than one in itself. So they give you some examples: 4, 6, 8, 10, 12. So 4 you can divide by 2, 6 you can divide by 2 and 3, 8's 2 and 4. So we see we can divide those by things other than just 1 and whatever the other number is. 0 and 1 are special. They are not prime and they are not composite. They're just special, so don't include them with prime or composite. When we do prime factorization, in my opinion, the easiest thing to do is make what we call a factor tree. And a factor tree just looks like this. You put the number that you're factoring at the top, and you want to think what product equals those numbers. So we are always thinking of multiplication. So here they use 4 and 10 because 4 times 10 gave me 40. So don't use like 20 and 20. 20 times 20 is 400, not 40. So always think what two numbers multiply to get the number that I want. So here they showed you a couple of examples where they factored 40, but they wanted to point out that they used different numbers at the beginning. So here they use 2 and 20, here they use 5 and 8. But no matter what you factor your numbers into, as long as they multiply together to get the number you want, you're going to get the same answer. So just use whatever numbers work for you, whether that's smaller or bigger numbers. So whenever we make a factor tree, what I like to do is circle all my prime numbers as I go. So here, 2's prime, 2's prime, 2's prime, 5 is prime. So I circled 2 3 times, which is where they got 2 cubed, 5 once, so they only have 1 5. Same thing here, 5, 2, 2, and 2, so 2 3 times, 5 once. So I just like to circle it just to keep my work organized and I can immediately see what the prime numbers are. To decide if a number is composite, you can list all of the factors. For example, if we're trying to figure out if 9 is prime or composite, some people just jump to it being prime because it's odd. That's not true. We can divide 9 by 3, so 3 would be composite. Okay, turn over to page 51, please. The think about it says, why do you think you'll always get the same prime factorization for a number, no matter how you make the factor tree? Well, that is because you will always get the same answer since you are only, oh, that looks silly. You are only using numbers that multiply together to get your wanted number. So no matter how you multiply different factors, you still get the same result. So an example is if I wanted to factor 20, I could do 2 times 10, which is 20, but I also could do 4 times 5 times 20. So it really doesn't matter what numbers you pick because as long as you're choosing factors of that number, they're going to multiply to get the number that you want, so it's okay. Next, it says we're going to figure out the prime factorization of 20, and they're going to walk us through that a little bit. So we're going to come back to this tree diagram after we answer our questions. So first, they want us to list all the factors of 20. So I want to think, what can I divide by 20 and still get a whole number? So I can divide it by 1, I can divide it by 2, 4, 5, 10, and 20. So here, it says fill in the missing factors in the factor tree above. So I need to think 4 times what is going to give me 20? Well, that can be 5 because 4 times 5 right here gives me 20. Next, they want me to list the factors of 5. Well, the factors of 5 are 1 and 5. I can't divide it by 2, 3, or 4 because I'm going to get a decimal. So is 5 prime or composite? And explain. Well, it'll be prime because only 2 numbers go into it evenly. Or you could put it only has 2 factors, 1 and 5. So 5 would be a prime number. So if I were doing this myself, I would have circled it. Next, we want to list the factors of 4 because I have 4 in my tree diagram. So the factors of 4 are 1, 2, and 4. So is 4 prime or composite? And explain. This one would be composite. The reason is because it has more than 2 factors. It has 3 factors. In prime factorization, any prime factor that repeats is written just once using an exponent. So first, before we get there, let's fill out this table. So I think what times what is 4. Well, I don't want to use 1 and 4 because then I just have to factor 4 again. So I'm going to use 2 and 2. So they want me to use an exponent to express the repeated factor. So the 2 is repeated. I can write 4 as 2 squared. So since I had 2 2's, that's 2 squared. So next, use the expression you wrote above to write 20 as the product of prime numbers. So I always start with the smallest number, so the smallest prime, so 2. I had 2 of those. And then it says product, so I know I'm multiplying. 2 squared times my only other prime number was 5. So the answer should be 2 squared times 5. Okay, you should be on page 52 now. It says you can often find multiple factor trees for numbers. The prime factorization will still be the same. So we're going to make 2 different factor trees to find the prime factorization of 84. So first they want me to list the factors of 84. The factors of 84 are 1, 2, 3, 4, 6, 7, 12, 14, 21, 28, 42, and 84. So they want me to choose any factor pair and put them in the factor tree. I'm just going to choose 4 and 21. Next, it says, are either of these factors prime? 4 is not, 21 is not, so no. So just because 21 is odd doesn't mean it's prime. If it's prime, you cannot break it down farther. They weren't prime, so I'll move on. Look at any composite factors in the factor pair. List their factors. So factors of 4 are 1, 2, and 4. And factors of 21 were 1, 3, 7, and 21. So now they want me to continue the factor tree until all the numbers are prime. So 4 would break down to 2 and 2. So circle them because they're prime. 21, I'm going to use 3 and 7. Both are prime. It says, how many factors do you have? Or I'm sorry, what factors do you have? So we circled 2, 3, and 7. Do any of the factors repeat? Yes, the 2 repeated. If so, write these factors with an exponent. So since there were 2 2's, I write 2 with an exponent of 2. So that exponent is how many times you see that number. Next, write the prime factorization of 84. So the smallest number I circled is 2, circled it twice, times the next number I circled is 3, circled it once. So I could put a 1 there if I wanted, but I don't need to. Then I circle this 7 once. So that would be the prime factorization. Okay, moving down. I'm going to do the same problem again, but this time they want me to choose different factors. So this time I'm going to choose 2 and 42. 2 is prime. I can break down 42 into 2 and 21. 2 is prime. Break down 21 to 3 and 7. So what factors result from this factor tree? So again, we got 2, 3, and 7. Is the result of this factor tree the same or different? And it's the same. I had 2 2s, I had 1 3, and 1 7. Okay, please go on to page 53. Use what you know about prime factorization to answer this question. Bria and Levi are finding the prime factorization of 140. Bria starts with 10 and 14. Levi starts with 2 and 70. Draw the two factor trees, write the prime factorization under each tree. So 140, I can factor that into, well, Bria says she's going to factor hers into 10 and 14. 10, I can do 2 and 5. So the most common mistake here is people are putting 5 and 5. 5 times 5 is 25, not 10. For 14, I can do 2 and 7. All of those are prime. So you have a blank down here, so please put that in the blank. The smallest number I circled is 2, circled it twice. I circled a 5 once and a 7 once. Next, Levi chose to do 2 and 70. 2 is prime. 70, you could do 7 and 10. 7 is prime. For 10, you could do 2 and 5. So on your blank, the smallest number I circled is 2, circle it twice. Circle a 5 once and a 7 once. So notice we got the same answer because it doesn't matter what we pick as long as we are using the correct factors of those numbers. Okay, we have one more page, page 54. What's the prime factorization of 63? So I'm going to put 63 at the top of my factor tree. So I need to think what times what's going to give me 63? Well, 9 and 7 do. 7 is prime. 9 can factor down to 3 and 3. So my answer, circled a 3 twice and a 7 once. Number 2, the diagram shows a factor tree for a certain number n. Part A says what's the prime factorization of n? So I just look at the prime numbers that I was given. Smallest number is 2, circled it once, then 13 twice. Part B, what's the value of n? So since I'm always thinking multiplication, I need to figure out what's 13 times 26. So let's do that on the side. 6 times 3 is 18, carry my 1. 3 times 2 is 6, plus 1 is 7. Done with that. I'm going to bring down a 0. 1 times 6 is 6, 1 times 2 is 2. Then add those. 8 plus 0 is 8, 7 plus 6 is 13, carry the 1, 2 plus 1 is 3. So the value of n was 338. So prime factorization of 338 is apparently 2 times 13 squared. Okay, last one. Number 3, make a factor tree to find the prime factorization of 120. So I got 120. I'm going to factor this to 12 and 10. Both are composite. 12 can factor into 2 and 6. 2 is prime. I can factor 10 into 2 and 5. Both are prime. And 6 factors into 2 and 3, which are both prime. The smallest number I circled was 2. I circled it 3 times, so my exponent's 3. Circled a 3 once and a 5 once. So 2 cubed times 3 times 5. Okay, so now that we have done the part that we typically do together, you are going to do pages 55 and 56 on your own. Keep in mind I will be grading this, so finish that. When you're done with that, go ahead and put it back where it goes in the classroom, and then carry on with the rest of the module. If you have any questions, feel free to ask me.